Hello! In this work, you will determine the values of surface tension coefficients for some solutions and will observe the effect of surfactants on those. For starting, let's introduce some useful theoretical notions. The interface is the surface layer that separates a liquid from other mediums, such as a solid, a gas, or an immiscible liquid. Adhesion and cohesion forces act upon the molecules of the interface. The resultant of these forces is called surface tension force, and it's always oriented perpendicularly on the interface. Due to these forces, the interface behaves like a stretched elastic membrane that exerts a continuous pressure to the liquid body. The surface tension forces are quantified by the coefficient of surface tension, which is commonly represented with the Greek letter sigma. Apart from the nature of the interface, the values of this coefficient depends on the solution's composition and temperature. A surfactant is a substance that, when dissolved in a liquid, self-assembles mainly on the interfaces, lowering the surface tension of that liquid. Examples of surfactants in human body are the pulmonary surfactant, with critical role in the gas exchange, and the biliary salts, with function in the digestive system. In this work, you'll determine the values of surface tension coefficients for three solutions using the stalagmometric method. This method is indirect, relative, and dynamic. To this end, you will use a burette, three solutions for study, distilled water, and two beakers. The burette is a graded cylinder with a tap at the lower end. Attention! At the start and end of the experiment, as well as every time you change the studied solution, rinse the interior of the burette with distilled water. Using a beaker, fill the burette through the funnel at the top end. Open the tap to empty the liquid into the accumulation container. First determinations will be performed for the reference solution, which, in this case, it's distilled water. Fill the burette with distilled water till above the mark 0. Open and adjust the tap in a way that allows you to count the falling drops. Count the number of drops in a volume of 5 ml of solution starting from any mark of the burette. For example, starting from mark 12 until 17 or from the mark 13 till 18. Perform 3 measurements of the number of drops and write the obtained values in the table of your lab book. Repeat these steps and perform 3 measurements for each of the studied solutions. Attention! After each measurement, don't cast the solutions. Put them back in their corresponding container. Fill the table with all measured data and calculate the mean values of drop numbers for each solution. For distilled water, the values of density and coefficient of surface tension are given in the book. The densities of studied solutions are marked on their containers. Finally, calculate the coefficients of surface tension for the studied solutions using the given formula.